So let's do this. Let's insert the inner plate first. And let's do the outer plate too. Man, my bad. So then, as you can notice, so let's do the front and the right here. So this is the perspective. So they're laying down. So let's flip them to the right configuration that we want. 90 degrees, rotate this way. 30 degrees, and rotate this way. So we'll be doing, let's say, it doesn't really matter that much where it is placed, but like I only do this to make it like make more sense logically. So now we can fix this. So right now we're going to do the left side of the drive base first. So I'm going to fix this. And another thing you can see is that in this official design, there is basically a channel is the thing that's like basically the width between the two plates. So if you go back to Go Build Out, we can know the width by just checking the thing. So as you can see, the width is 48 millimeters. So we can just use 48 millimeter standoffs in this case. So we can do insert, other documents, FTC, parts users, Go Build Out, structure. We can do either do beams or we can do standoffs. So let's just do standoffs, M4 standoffs, and we don't need to import them one by one here, so we can just do this stand-up configurable one. So let's do 48. Great. Done. And let's just make 4 copies. 1, 2, 3. Great. And then we can press mate to start mating. So these are M4 holes. So you can see here, like, these are M4 holes and these are M3 holes. Oop. Last one. Done. Now what you can do is you can attach this plate on there now. So flip direction, kind of make sure this is right, and done. So now we have our module now. So let's put in the wheels. Let's insert the wheels. Other documents. So as we made this copy of this file here, so we can see this file here. So we can have the full wheel here. Let me see. Why did these two parts get imported at the same time? So let's just make this into a group, just in case, to make it simpler. Because for the parts just to not fall apart. Yeah, you see, now what this happened. So make this a group, so it always stays together. And then we need to find the right orientation of this. We choose, or we can just do this basically. Choose the inner part here. Make sure it's the right orientation by flip this. And this seems right. You see, it fits perfectly. And note, so we need to view this from the top. This is something to note. So viewing from the top, the wheel should be in an X-shaped configuration, essentially. So there is a left version and a right version. So let's see how did they handle that in here. I remember they have wait a sec. I'm imagining things right now. I assume they have a full drive base. Yeah, they do have full drive base. Assembly 1. So why did that disappear in my example? Oh, okay, here. So you can basically configure stuff. You can basically configure a simple drive base in this scenario. But yeah. So like in this case, essentially, this is a configurable file, which is what makes it a little bit annoying. So what I am probably gonna do here is I'm gonna make an example. I'm gonna import back from this old decode cat file. So as you can see here, there is a mirrored version of this, so good. We can just use those. So ignore this, let's just delete this. Control Z, delete this. Bye bye, annoying thing. Let's just go to our other documents. You'll probably go not into the owned by me, but into like a shared with me folder. And then assemblies, or actually parts. Mirror. Yeah. So left. I'm going to import a left one and a right one. Come on. You can do this. Laptop, I believe in you. Great. And a right one. Or drive. Okay, so this is like mirrored, so this is like technically the right one. Great. So let's view from the top how we're going to place it. So as we know, we are planning to make this the front side, so we need to make this look like an X from the top down. So to make this look like an X, this drive will be going up in front to make it look like an X. Oh dang, I need to make this a group too. So annoying. Group it. Group this too. They import it as individual parts and not an assembly, so you do that with anything that you just get annoyed with and you just don't really want it to move around. Like, so let's do this. Choose this. Make connector. Choose this too. Revolve, revolve, revolve. Perfect, fits in. And let's do this one too. I believe I chose this one, so oops. Yep, fits perfectly. So as you can see here, there's not really an overlap in any parts. This is basically perfect. Okay, great. So now we have one side of the thing. But no, we do not have any standoffs in here, so we're going to be adding some standoffs a bit later. Another thing to note is that we have no way of connecting these two together, like this side with another side together, which is another annoying thing. So we're going to learn how to do that a little bit later. So also, another thing we want to note is that we do not want to obviously kind of assemble all these parts on the other side as well. So I'm going to show you how to do a mirror in an assembly. So also let's create a folder too. So left. This is the left, right? I'm not dumb. So let's move this up, and then we can move everything here into the left folder. Oh no. Yeah, so now they're all in the left folder now. So now we need to focus on how are we going to add standoffs to make this stronger, and how are we actually going to connect this to the other side. So in this, so like in this season, what we did. Oh, this is so dumb. We did what like this. We had a rather unsecure connection in that season. So as you can see here in this example, it's not the most what do you say, secure connection ever. So it's basically we do not have connection in the front here, and we have connection with a single beam on the back. So you can see here we have like this beam here, only beam, and this is not very secure. But the good thing is that we have this aluminum bottom plate, and which made it a lot stronger. And like the bowls here, like the bowl that holds the ball here, also acts as some sort of support, so it's kind of helped with that. But in this case, in other cases, you might do something different. So let's do something similar to the other parallel plate drives. So we're gonna have, we can just have two channels in the middle. Sounds like a really good idea, right? So like in this decode season, the ball kind of needs to, the intake needs to be low, and there needs to be transfer up. So like this space needs to clear out as much as possible. But in other seasons, like the next one, I don't think it will be that necessary to do something like this. So let's just do, but like we still need to like kind of keep a bit of more space in the front for installing some other things. So we're going to try to move our two channels to the more later half here. So let's start. All we need to do is that we can just start editing in context. This is a very good part about Onshape. Edit in context. We need to take advantage of all the things that we can do. So let's do this. Sketch. Oh, this is annoying. So as you can see, this is the front and this is the back of the thing. So actually we can just do view normal to, and then we need to go to checkout, go build a. So we're gonna just place U channels here essentially. So we need to check out the CAD of a U channel. Essentially, let's just check this for example. So the dimensions of it is 48 by 48. So let's do two of these channels, and we're gonna space these two edges around. Let's space the center of them around 48 plus 16 millimeters. No, plus 24 millimeters away from each other. So they're, and as you can see here, there's no way else for us to connect these two beams in the middle without something else. So another thing we need to consider is we need mount. So the mount we're going to use is a quad block mount. So these just go straight in. We have a ton of these. So as you can see here in this example, they are made just perfectly for this purpose exactly. So as you can see, they have mounting holes. So this is 1, 2, 3, 4, 5. 5. So like it's 4 times 8,